Adaptive thermal comfort model suitable for outdoor considering the urban heat island effect. My name is Ivan Oropesa. I'm from Universidad de las Américas Puebla in Mexico. The outline is given by the characteristic of the urban heat island effect. The outdoor thermal comfort survey made developed here. The numerical outdoor thermal comfort model just based on the survey, the values of the equivalent outdoor sensation of comfort, the sensitivity analysis, and finally the conclusions. In the case of the urban heat island, we have three main heat flows given by the emitted heat, mainly from the surfaces, the waste heat from the motor traffic, and the direct solar radiation. This given the urban heat effect, and this given the thermal discomfort. We developed a survey just headed to architectural students, the bachelor degree in the Universidad de las Américas Puebla here in Mexico. The Puebla city is just located at 100 kilometers from Mexico City. This given has a climate condition of CWB according to the Copper classification. This is a dry winter subtropical highland variety. The human heat island is really presented when in this case of on this kind of climate conditions. The proper temperature, proper humidity, low direct radiation, low diffuse radiation, cool breeze, proper clothing, and proper activity are the 7 variables considered to answer to the people. There are 23 females, 18 males. The range of the ages are from 19 to 22 years old. And even answer is given by the numerical value. In this case of no is 1, partial is 2, and yes is 3. With this and the two kind of context. In the case of the no urban heat island is rural context, and with the yes urban heat island is in the lower picture. In the case of this, they suppose we tried to have the same conditions, the climate condition, and as well as the conditions of the students, closing and metabolic rate, in order to have similar conclusions. In the case of the no urban heat island, we consider or we have that the thermal discomfort is given in most of the people, in the general perception, and the opposite on the urban heat island is presented. The thermal discomfort is all the time, or most of the answers are given that there is no thermal comfort for the people. So with this, we have a numerical outdoor thermal comfort model. As we said, they say we have one value for no answer, 2 for partial answer, and 3 for yes answer. With this, we have these values, and we have a standard deviation calculation. We found that the results are consistent, and with this, we developed this EOSC, equivalent outdoor sensation of comfort. With this equation, we can have the comfort values. If we have the inputs in this equation with these values of comfort and the ratio of the comfort, we can get a 0 value. If we have the extreme values, when this, for example, the temperature 45 degrees, proper humidity 100, etc., we can have an EOSC value of 12.6. This is the highest we can get. In between, they have the upper boundary values. If we have the proper temperature of 28, this is the upper threshold of 75% of relative humidity, etc., the EOSC value that we can get is 2.7. You suppose there is a range between 0 and 2.7 when the temporal comfort is presented to the people. You suppose this is the meaning of this equation. With this, we have a sensitivity analysis, and with this, we can conclude that only alone outdoor temperature and direct solar radiation, they can get EOSC values higher than 2.7, just alone. If we have a combination, of course, we can get another values. The conclusion of this, we can say that only the outdoor temperature and the direct solar radiation are able to reach the EOSC values higher than 2.7. However, we can get that the closing and the metabolic rate of the people have a certain influence on the EOC when they have alone. And with this, we can conclude that for lowering the outdoor temperature and the direct solar radiation, we can get some urban approaches such as green areas, vegetation, and urban shading. And of course, for example, as well, high reflectivity of the materials, the urban materials or urban canons. But the most important thing is we can have a combination of both urban and user approaches in order to have EOSC values or closer to 0. That means that we have a thermal comfort. So in the end, this is the conclusion of the work. Thank you for listening, and if you have any question or any comment, please do not hesitate to send me an email to this email address just over here. Thank you very much for listening, and have a nice day. Thank you.